So, as we start on this new prompt, I'd like you to go ahead and start this new habit of studying too. Don't forget, once we're done with this, there's a home component that that you could actually go up and watch it again. But here's the problem that I have here for you. The area of a triangle is 20 square centimeters. Okay, so I just talked to you about area of different shape. Well, right now we're using a triangle again. Can anyone kind of remind me what the formula for the area of triangle is? Yes. Half times base times height. So I'm going to start with that. Okay, so basically the area of the triangle is half base times height. Fair enough. I need that to have to start the problem. And then I also know something, that the area of this triangle is exactly how many square centimeters? 20. So that means I can replace that A and write this. What are the possible whole numbers dimensions for the base and height of the triangle? So what am I saying here? What I'm saying is this. First of all, you take some random value of the base, some random value of the height, multiply them together, and then cut in half to get 20, right? So before you cut in half, what is the base times height going to get you? 40. Because 40, half of 40 is exactly 20, right? So 40 is our target number. So I'm just going to go and write it again, right here. That's what we have. So base times height will give you 40 before we cut in half. So what I'm asking is, can you give me all possible, notice I'm saying whole number. Whole number means no negative and, of course, no zero, right? In this case, we don't want to have zero there because if you have zero, then you end up with a zero area. So can you give me all possible combinations of different base and different heights to make up 40? Give me one. Yes, Jenny. 20 times 2. So you're saying 20 times 2. Very good. 20 times 2 is indeed 40. Yes, Jennifer. 5 times 8. So 5 times 8 is another one. And Nicholas?
4 times 10.
4 times 10. Okay, and anyone else? Yes, Isaiah.
1 times 40.
Exactly. 1 times 40. Okay. Do we have any other combination, or is this the only? These are the only possible combination that we can have. Yes. No, switching is the same thing. Remember, because multiplication is commutative, there's no point in switching. 40 times 1 is the same thing as 1 times 40. Okay, anything else? Why don't we use negative in this case?
Because it's not a whole number.
Very good. And it doesn't make sense to have a base that is negative, right? Not that it doesn't work when you say negative 2 times negative 20, which is still 40, but then again, we don't have a negative height and negative base. That's why we don't use negative numbers. But I'm saying, if I don't specify that it has to be whole numbers, you can certainly use negative numbers, right? If I just say regular integers, you can certainly use negative 20 and negative 2. You can certainly use negative 5 and negative 8. Okay, does that make sense so far about this?
Yes.
So I hope you see what we're coming down to, okay? This is like a foundation to what we're going to be learning this whole chapter. Isaiah.
How do we know what the base times height?
Oh, I'm just using, no, any of these can work.
Yeah, but is there like a certain answer?
Oh, well, I said all possible, right? I mean, it can take on different shapes. This triangle can take on different shapes. It could be thin, I mean, it could be like a tall triangle or a big wide triangle, but either way, it will work out to give you 20 centimeter squares, okay? So I want us to start looking at this right here as a foundation to chapter 8. For chapter 8, yes, you'll be looking at a lot of different combinations, products in this case, to get you the number that you want. But for us to find this kind of combinations, there's a tool that we can use. And you have seen this in the past, and I want to go ahead and start us with that today, and that is called factoring. Remember that?
Yeah.
Factor tree, anyone?
Oh, it's
I
probably
love the
one.
factor
Remember that?
tree.
Okay, good. Do you also remember about prime numbers?
Yes,
Yeah.
yes.
Yeah.
2 and 3.
Okay. Can anyone tell me what is your exact definition in your own words, please? What is a prime number to you?
Prime number is something that can only be there's only 2 numbers that can be
Okay, be more specific than that. Yes, Kasala. Shh. Listen, please. What's the prime number to you?
Something that is multiplied by itself and it equals to that prime number.
There's more. Yes, Jennifer.
The prime number is a number that is factored into only two numbers, and the number is 1 in itself.
Okay, so basically there it is. A prime number is a number that can be actually factored into 1 and itself, and nothing else. So for example, can you give me one prime number?
13.
13. Because notice that you cannot find two other numbers that multiply together to get 13, except 1 and 13. 1 in itself. Anything else besides 13? Yes. 7.
I was gonna say that.
Okay, give me another one. 2. Yeah, 2 works. Yes. 1 is actually not. Yeah.
1 is
Yeah. So 1 is definitely not prime.
23.
23, 5, 11, and so on, right? Okay, so we talked about that. I want you to understand what prime is, and so give me a number that has not prime.
12.
12, why?
100.
Because you can multiply it by 1 times 3 and 12 times.
Yeah, exactly. And that number is called what, do you know?
Composite.
A composite. So we're all clear between the difference between a composite number and a prime. So go back to what we just covered before. By the way, the topic today we're going to learn about is called factoring, right? And we start off with the number 40. And of course, right now, you know that 40 is not a prime. Because how many combinations did we just find for 40? 4 combinations, right? So because we have multiple combinations like that, that number is definitely not prime. If that number is prime, we only have one combination. That is 1 and itself. That's it. But 40, as you can see, we have 4 different combinations. Let's list them out again. 20 times 2. The other one is 40 times 1. We have 8 times 5. And of course, we have what? 10 times 4? Right? So these are the 4 combinations we came up with. But do you also notice that you're not able to come up with a different combination every time? Is there a way to see it? Well, this way is called factor. So we take 40 and we break it all the way down to the prime level. Yes?
Oh, wait, I don't know what to do.
Okay. Well, we have several ways. We talk about the factor, do the ladder method, keep on dividing, or you do a factor tree, or you just go ahead and start breaking up in your mind. 40, for example, you break it down. What 2 numbers will give you a product of 40?
22.
Huh?
22.
Okay, let's use that first one. 20 times 2. And then what I'm seeing is, well, that 2 is already prime, right? So I don't have to do anything with that anymore. But 20 here can certainly get what?
2 times 10.
Okay, so 2 times 10. Notice I'm still carrying a 2 over,
And
right?
then 10.
And the 10 is 2 times 5. And notice that these are all prime, right? So I can certainly write it, expand it as 2 times 2 times 2 times 5. Always check to make sure. And of course, people will love to do it this way. 2 times 20, and you would just go and break it down. Oh, every time I see a prime, I circle it to indicate that I'm done with that branch. So 20 times, well, in this case, 10 times 2, 2 times 5, prime, prime, and you get the same result. So I don't care how you want to approach this kind of problem, breaking it down. You certainly use the factor ladder, the factor tree, doesn't matter. Okay? Any questions so far on how to do this? Okay, but here's the thing though. Once you have it factored completely, do you notice that you can actually use the combination of your factors to make up all the possible combinations you have here? For example, watch this. 2 times 20, right there. Next one. 4 times 10, well, right there. Next. 8 times 5. See that? And of course, last one. You have the whole thing, which is 40, and you know that there's always 1 in there. 40 times 1.
Oh, there's already.
So that's 4. Okay? So this is just another technique for you to start making up different combinations using your primes. Okay? Any questions so far?
No.
Okay, let's try another one. So you can actually break it down for me. Easy, right? Okay, let's try this number. 48, a to the third, b to the second. Break it down.
I got you.
Okay, go ahead and break that down for me.
I've never dealt with variables.
Variables the same way. We just learned
Oh, okay.
how to take b to the third or b to the second apart. Did you know how to take it apart?
Yeah, just write it out.
Exactly.
Oh, okay.
Alright, that's how you factor it. And I hope you see when you factor your variable, your power with the variable, you just break it all the way down to the very first power. Okay? So don't feel shocked to see that. I mean it's the same way.
I broke it down.
Okay, 48. Let's start with 48 then. 48, what can you break down to? 6 times 8,
Oh, 6 times 8. No,
right?
it's 42.
Okay. Are these 2 prime yet?
No.
No. So you have to break it down till you hit the prime level. What about 6? Can you break down 6?
3 times 2.
Okay. Are these 2 prime?
Yes.
Yes, so I circle them. Next, 8.
4 times 2.
4 times 2. I realize that 2 is prime, but 4 is not.
2 times 2.
And 2 times 2. And the benefit of circling is to indicate that, hey, I'm done factoring for that branch. I'm done. So now, all you have to do is just count all the circles that you have and put it back in. So for 48, I would have 1, 2, 3, 4, 2. So 1, 2, 3, 4, and then 1, 3. If you actually test it, you multiply them all back in, you get your 48. And of course, for the 8 to the third, yes, so Renfrey.
Can you put the 2 as the power?
Yes, as a short form, you're right. But I want to leave it as a long form because I want to find my different combinations as well. But either way is fine. A to the third simply means A times A times A, and B squared means B times B. This is called,
John Russell.
not here.
5.
It's the second period.
5.
Okay, so this is what we call the factored form. And what do you notice about factored form? All of your numbers are all prime. Your variables are all in the power of 1. That's called factored form. Okay?
So all we do is figure out the number and then mark it out. So messy.
Okay? Alright. Any question on that? Now, let's go back and figure out our combinations. For 48, I know you can start with 6 and 8. Anything else? 148, that's the easy one, right? But once again, I want you to start using this too. Notice that we can say 2 times 24. See it? And that makes sense. Look, this is 8 times 3, 24, 2 times 2. So 2 times 24, that's one combination. We got 4 times 12. See that? So 4 times 12. And of course, this is where you get the 8 from. Look, 8 times 6. See that? So it's 8 times 6. And of course what? And this is something you probably missed. Look at this. You have 16 times 3. See it? And the whole thing now, which makes it 48 times 1. All different combinations, right? Okay, so keep on trying basically to come up with different combinations. Trust me, we'll help you later on. Okay, any question on that yet?
This is easy, I like it.
Just like the last chapter.
Yeah.
Huh? No. I was up the previous one. That's what he said. He likes it. It's easy.
Well, I like this part of it, but then when we get more into the chapter, then it's harder. Then I'm like, okay, wait, no, I don't like it.
Well, that's why you just need to keep up with us, right? Okay, next one. So we know how to factor it. We know how to find different combinations. We need to start looking for, let me bring this term up. Hopefully you remember. GCF?
Yes.
Remember that one? Greatest common factor. Okay, now, once again, in your own terms, words, can you define me what a GCF is to you? Yeah. Okay, it has to do with the biggest, okay? No, not just the biggest number. It has to be something else. Yes. Biggest?
The biggest
Well, that's why it's
factor?
GCF. I want in your own terms now. What does it mean to you? Yes.
It's the biggest numbers to multiply to get the number that you factor in.
Not quite. Yes.
The biggest number of 2 or more terms.
Yeah.
There's more to them, to that. Anyone else? Yes.
The biggest number that appears more than once.
No, not quite. See, this is the reason why some people are still struggling finding the GCF. Because you don't know what it really means to you.
Greatest common factor.
Yeah, what's it? I know, greatest common factor. But what is it?
The biggest number?
Yeah.
The biggest number that when you add it at its term, the end of the term is a prime number.
Okay, you see how complex that thing is?
I just said it just fine.
Okay, now. Okay. Instead of giving you a complex definition of that, do you notice that every time you try to find a GCF, well, let's start with this. Let me give you a couple examples, perhaps that will make more sense. For example, I have 8 and 4. What is the GCF here? 4. Why 4?
Because it's the biggest number you can divide with.
Okay, you can divide division. Okay. You just brought up the word that I like to hear. Divide. So, why 4 again?
Because you can't divide the thing.
And that's the biggest number you can actually divide both by? That's what you're looking for. So basically, it's the biggest number that you can actually evenly divide both numbers into, or multiple numbers. Okay? So this is a 4 because 8 can be divided by 4, and 4 can be divided by 4.
Yeah.
See that? So it's the biggest number, or I should say the biggest divisor you can find. Okay? So it involves division in a sense. And let's see another one here. What about 28 and 16? What's your biggest divisor here? 8? Okay, let's try 8. Is 28 divisible by 8? 4. See that? 7 and 4. See it? So it works. Definitely 4 is your GCF. But then you keep on asking, well, okay, instead of guessing like this blindly, is there a way to just get to the answer with some work? Exactly. That's what we learned as our first step. We factor. So here it is. Watch what happens. So we're going to start with the same problem again, the 2. 8 and 4 first. Watch what happens. I break it down. For the 8, don't you get 2 times 2 times 2?
Yeah.
For the 4, watch what happens. Every time I see a common term, I cross it out at once. And then I multiply them. And that's how I get 4.
I remember
Okay,
that.
this one, 7 times 4, right?
Yes.
And this is 4 times 4. Oop, like term, there it is. 4.
Uh-oh.
I remember doing that, but I got it confused with these comments.
LCM.
It's like
Yeah.
doing fractions.
Okay, you see that? Alright, I'll try another one here. Let's see if you actually factor this for me.
Hate fractions.
And 48 and 32. Can someone think of that for me? 48 and 62. I mean, sorry, 48 and 32. Work it out before you tell me what it is.
8.
Not 8.
Yeah.
16.
16.
Okay. Now, those of you who can actually think of that in your head, good for you. With practice, you can. But if you can't think of it in your head, expand it. 48 is what? What's 48? Can you give me a factor 48? 6 times 8? Okay. What about 32? 8 times 4, 2 times 16, fine. 2 times 16. It doesn't matter. Shh. You look at this right now and say, wait, there's nothing in common yet. Then keep on breaking it down. So 6 is 2 times 3, right? 8 is 2 times 2 times 2. Okay, see? 6 times 8. I got that part covered. 2 right here, still here. 16 is 4 times 4. But then you have, break it down. Is that how it is? 4 times 4 is 16. 16 times 2 is 32. Watch what happens. Common. 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 1, 2, 3, 4. So that's 16. You see how that works?
Yeah.
So you have multiple common terms, you just multiply them in the end, and that's how you get your GCF,
I like it like that.
greatest common factor. Okay? You see how it's done? 34. Okay. Any question on how to find a GCF? Last problem here, before I give you a quiz.
Wait, is this the lesson?
Huh?
The whole lesson?
Yeah.
That's easy.
Okay. Well, you just break it down. Okay. Try this one, please. I got myself I don't know, 72 and 45.
Oh my god.
I got this to be a to the 7, b to the 3rd,
All you have to do is just write that
a
at
to
the
the
end.
5th, b to the
It's
8th.
not hard.
Go ahead,
Yeah.
find your GCF.
Write it out.
We know the factor, right? We know how to cross out like terms. So try that.
It's not 5.
72. Can anyone make a
8
breakdown?
times 9.
8 times 9.
I don't like this, bro.
It's not 6. I mean, it's 9.
8 times 9, you said. Okay. Notice I'm still focused on the numbers. What about 45?
8 times 9. 9. 5 times 9. 8 times 9.
8 times.
Okay. Do you notice that as soon as I see something coming, I don't have to break it down all the way? I see the 2 9s can come, right? So I can just go ahead and use that.
Yes.
So, but then I know that 8 broken down is 2 times 2 times 2. There's nothing coming, so I can leave it. What about the A7, A5? Aha. Very good. This is what you see. We break down A7. You have 1, 2, 3, 4, 5, 6, 7. And then down here you have 1, 2, 3, 4, 5. So the maximum number of A's that you can actually cancel out is how many A's? 5. 1, 2, 3, 4, 5. So A5. Do you see a pattern yet for variable? You always, notice, you always select the lowest power. Because that's the maximum number of variable you can actually cancel out at one time. You have 7 A's and you have 5 A's. You can only find 5 A's that are in common. In this case, instead of writing B 3 times on top, it's B 3. Okay. And that's how it is. So when you see variable, you shouldn't feel afraid because that should be the easiest one to get the GCF. You only take out the lowest power. You see it? The one that has the lowest power will be your GCF. Question on that? I mean, you can certainly see by me expanding A7 times and A5 times that you only cross out 5 A's. That's why it's 8 to the 5th, which is also the lowest power here. Okay, any question on that problem? Yes.
Why do you don't subtract this? You did.
I don't know. We're not dividing. Remember, we're finding the GCF. Okay. All right. Questions? Don't mix this up. We're finding the GCF here. We're not dividing. Okay. We're not dividing like last one. Okay. All right. With that, now I want you to go and start in this problem.